Hello, everyone. Welcome back to lesson 7 of Machine Learning Zoomcamp session 1, number 1. And in this lesson, we will talk about NumPy. So previously, you installed, you configured the environment, you installed all the libraries we needed, you installed Python, NumPy, Jupyter, Pandas, and other things. And now in this lesson, we will do a quick introduction to NumPy. I'll show you the functions I use quite often from NumPy and things that will be quite useful in that course. So let's start. So we have NumPy already. So now what we need to do is import it. So to import a package in Python, use import and name of the package, import NumPy. But typically what we do is we don't just import NumPy, but we use an alias. This way it's shorter to write. So instead of writing NumPy, we can just write NP. So this is a convention. So usually in Python, at least in data science, this is how you do this. So we'll start with creating arrays, and the simplest method for that is called zeros, simplest function. So it takes one argument. This is the size of the array, and it just creates an array of this size, of the specified size, with zeros, right? Can be, let's say, 10. There is a similar function to that one called ones. Instead of filling the array with zeros, it fills it with ones. Then yeah, it creates an array of size 10. And then if you want to fill an array with some arbitrary number, so then you use a function called full. So first you specify the size of the array, and then you specify the element you want to fill the array with. So in this case, it's 2.5, an array of size 10. So this is how you create arrays with NumPy. And yeah, if you want to convert a, let's say you have a Python list. So 1, 2, 3, 5, 7, 12. So for example, we have this Python list. And if you want to create an array from this, you use a function called array, and then pass the list as the argument. And then the result is an array. So yeah, let's call this array A. Yeah, so we have the array. And if we want to access an element of this array, then let's say if we want to access element 3, which we have here, right? So what we need to do is we just write index 2. So remember, indexing in Python starts with 0. So then this is how we access the third, like in this case, element number 3. And likewise, if we want to change this to something else, let's say we want to change it to replace 3 with 10. So we just use the assignment operator. And here, after executing this code, here we have 10 instead of 3. Okay, a few other useful functions for creating arrays is one, a range. So this creates a range from, let's say if we want to create a range from 0 to 9, we use 10. So 10 is like the last element, not in it's exclusive. So basically up to 10. And by default, it's from 0 to 10 exclusive. So in this case, it's from 0 to 9. And let's say if we want to start with some other number, not with 3, not with 0, but with 3. So we just put another parameter here, and then it creates a range from 3 to 9. This is very similar to a Python function called range, right? So it's doing the same thing, except instead of giving us an iterator from Python, it gives us a NumPy array. Then another useful function in NumPy is called linspace, which creates an array filled with numbers between the first parameter and the second parameter. So let's say if we want to create an array with numbers from 0 to 1, So the first element of this array is 0, the last is 1, and then it just creates an array of size 10, of size 11, like we specify here, and it fills everything between these two numbers. And of course, like instead of 1, we can put anything you want here, and yeah, it will just figure out how exactly to fill it in. And so I put here 11, not 10, because if you put 10, then yeah, it will not be as nice. And if you put 11, it just looks kind of nicer because the steps are rounder. And so far we created just one-dimensional arrays, so usual arrays. If we want to create, in NumPy, it's possible to create two-dimensional and multi-dimensional arrays. So let's say if we want to create a multi-dimensional array, so we use the same function as previously, zeros, but here we can specify the dimensions of the array. So we can say that we want to create an array with 5 rows and 2 columns. So the first number here is rows, the second is columns, and then it creates an array with 5 columns, 2 rows filled with zeros. Right. In the same way, we can create an array from a Python list. So let's say we have an array, we have a list of lists in Python, 1, 2, 3, then 4, 5, 6, then 7, 8, 9. So this is a list of lists in Python. We pass it to the array function, and it creates a two-dimensional array for us. Right, so let's call it n, right? And again, if we want to access elements of this array, so we this is basically the same as with one-dimensional, except we have now 2 indices, and it's indexed with so it starts with 0, so 0, 1, 2 for rows, and 0, 1, 2 for columns. And if we want to now, let's say, access this element here, so element number from row number 0 and column number 1. So we use, so first we specify 0 and then 1. So it gives us this element, right? And then of course we can use the assignment operator. So if we want to replace this 2 with 20, so we just use the assignment operator, and then yeah, we see that it changes. So now we changed this element to 20. If we only want to access rows, then we, instead of passing 2 indices here, we can pass 1. And let's say if we want to get the 0 row, we just say row number 0, row number 1, or row number 2, right? So this is how we access the entire row. And again, we can use the assignment operator. Let's say if we want to rewrite the entire row, we can say, okay, the last row should be just once. We can say that. So we can assign using Python list or NumPy array, like the only condition that it should match the dimension here. So let's do that. And now we can see that the last row changes. And then the same we can do with, if we want to access a column, we can get the entire column if we want. And for that, we need to use only to specify only the second argument. But yeah, let's say if we want to get the second array, second column, we use 1, but we cannot leave it empty. So we need to put something, and we put the colon operator, meaning we want to get all the rows, but just keep the column indexed by number 1, and we get this. Second column here, right? And actually, this column operator means return all the rows, so we can just use that. Yeah, you see, it returns everything. And yeah, so let's say if we want to get the last column, this is what we get. And likewise, we can assign something else to this. Let's say if we want to reassign it to 0, 1, 2, we do that. And then when we look again at our array, we see that we managed to change it here, right? So this is the same array. So these are two-dimensional arrays. So next, what we can do is we can generate arrays randomly using this random package in NumPy. So let's say if we want to generate a two-dimensional array of size with 5 rows, 2 columns, this is what we do. So we just specify the number of rows, number of columns, and it gives us an array with random numbers between 0 and 1. So this is like a uniform distribution, standard uniform distribution. So, and every time we execute this cell, we get a different number. But if we want to make the results reproducible, and if you run this code, and if I run this code, we get the same numbers, it's possible to do this by fixing the random seed. Because these numbers, they are not really random, they are pseudo-random. So they are generated, and we can set the seed of this generator. And if we do this, the sequence of random numbers that is produced on my computer and on your computer will be the same. So let's say if we set seed to 2, then we get an array that looks random. So these numbers are random, but every time we execute this cell, the results are the same, right? Because we fixed the random seed, like the seed number here for the random generator. That's why if you execute, you probably will have the same one. It a bit varies depending on the version of NumPy or operating system you have, but in general, the sequence you get, the matrix you get should be the same as I get. And then, so here we sample from the uniform distribution, standard uniform distribution. There are many different distributions. So let's say if we want to draw numbers from the standard normal distribution, we just add an n here. So it's rand n, meaning n normal, and then the distribution looks a bit different, right? And then for integers, like let's say if we want to have numbers between 0 and 100, so one simple thing we can do is we can multiply every number here by 100. And actually, since this is NumPy arrays, we can just use that. And this is something I'll explain later in this section. But yeah, you can just multiply every element by 100, and then you will get, instead of having numbers between 0 and 1, you will have numbers between 0 and 100. But if you want, there is also a function that you can use for generating random integers. So you can specify here the lowest numbers, the highest numbers that is possible to get. I think it's this one is included. This one is probably excluded. So it's between 0 and 99. And then you can say that I want to have 5 rows and 2 columns, and it will generate you a matrix. And a two-dimensional array like that with random integers. So yeah, here we did this multiplication. Let me explain how it works. So I'll just create an array first, a range of 5. So it's numbers from between 0 and 5, 4 in this case, right? And we can do, let's say, what if we want to add a number to this array? So we want to add 1 to all the elements of this array. So what we can do is we can just write like that instead of writing a for loop. So if it was a usual Python list, then we won't be able to do this. We would need to write a loop and then add a number to each element. but NumPy makes it easier for us. We can just write +1, and it adds an element to each number here. Then let's say if we want to multiply by 2, then every element of this array, you can see, so 0 is multiplied by 2, this one is multiplied by 2. So basically every element is multiplied by this number. And this is what we used here. We just multiplied everything by 100. And of course, we can divide, add, subtract, do everything we want. And not only that, we can also chain them. So let's say we can first divide, multiply by 2, and then add 10. And then this is what we'll have. And even, let's say, take the power of it. So yeah, so we can chain this operation any way we want. And yeah, we can do that, and yeah, like whatever we want. Let's save it to a different array. So now we have array 1, array A and array B. What we can do also, we can combine these two arrays. So we can do element-wise sum. So we can take, let's see, so for B, yeah. So what we can do here is add element-wise these two arrays. So for first element, we would compute the sum. For second element, we would compute the sum. And you can see here that, let's say the last element here is the sum of these two, or the second is sum of these two. Basically, it does the sum element-wise. And again, we can multiply. We can also divide. We can do anything we want here, right? And then again, we can chain it with all these different operations. And then, yeah, so we can do that. We can also do compare numbers element-wise. So comparison operations are also element-wise operations. So let's say if we want to do element-wise comparison with, so let's say we want to see if elements of this array, which elements of this array are higher or equal to 2. And then, yeah, so let's print it. So we see that the first one is less than 2, second one is less than 2, but this one is higher or equal to 2 because it's 2, and then the same is true for the rest, right? So we can do this with elements, with just numbers, right? Or we can do it with other arrays. So let's say we can see which elements of array A are greater than the elements of array B. And then we see, okay, like this one is actually smaller. The second one is also smaller because 0 is smaller than 1. 1 is smaller than 1.44. But this one, like for this one, actually 2 is bigger, then 3 is bigger, and 4 is bigger, right? So that's why we have false, false, and then true, true. So we can do it, for compare elements of multiple arrays. And we can also see which elements of A are actually greater than B. If we write something like this, and let me execute it and then explain. So what happens here is, so this statement returns a Boolean array like that, right? So it returns an array with false, false, true, true. And when we do this, it basically returns all the elements of array A for which this condition is true, right? So we know that for this element, this condition is true, for this element, and for this element. And these are elements 2, 3, and 4, right? And this way we can look at all the elements that that satisfy this condition. So these were element-wise operations, and there are different kinds of operations that I call summarizing operations, because instead of returning another array like here, so when we do, let's say when we do this comparison operation, we compare A with 2, we get another array. But there are some operations that instead of returning a new array, return a single number. So an example of this is the min operation. So min returns the smallest number. In this case, it's 0. You can also return the maximum number, maximal, which is 4. You can also compute the sum of all the arrays, which is 10 here. So it's like 0 plus 1 plus 2 plus 3 plus 4 is 0. Or you can compute the average number, which is min. Right, so these are summarizing operators. There is also standard deviation if you're interested. And this is how you do this. And it, of course, works also for two-dimensional. So which one is we have let's say n, right? So we have this n. So we can also compute the sum of all the elements of m, n, or find the minimal number, and so on. So this is a quick introduction. There are, of course, a lot more useful functions in NumPy. So I'll include the link where you can read more about some of the things. So there are things like, let's say, if you want to find the minimal number in each row of your two-dimensional array, what do you do? Or what if you want to sort, and things like this. So for that, check the link. And in the next lesson, we will quickly go through the basics of linear algebra, and we will talk about the multiplication operations.